So we know this is a nice smooth curve, so it's obviously continuous, no corners, no breaks, so the derivative exists. If we were looking at the slope of the tangent line between 2 and 4, so here's 2, here's 4. So if I looked at the line connecting those, I'm asking you, when is the derivative, so the slope of the tangent line, going to be parallel to that? Where do you think it happens? Three, this tangent line would be roughly parallel. All right, this one, I'm looking between -1 and 3. So when my x is -1, it's down here. My x is 3, it's up here. So there's the tangent line, or the line connecting those two. I want to know when the slope of the tangent line would be the same. So that looks like about right there, assuming I could draw a straight line. So that one is about when x equals 1. I'm not going to be having you do this on your homework, but I just want to show you visually what it's telling us. If I look at this one, what's wrong with this? It comes to a point. What does that mean right there? It's continuous. Is it differentiable? No. So if there's a corner, we know it's not differentiable. If you looked at the line between 1 and 4, it's here. Do we ever have a tangent line that's parallel to that? No. So this one doesn't have any, but it doesn't violate the mean value theorem because it didn't meet the criteria to begin with. This one, what's wrong with this? The discontinuity. If we are looking at the interval 0 to 2, okay, here's when x is 0, here's when x is 2, that's a horizontal line. Is there anywhere between 0 and 2 where the derivative is 0? No. So again, it's not violating it because the original criteria weren't met. So it only works under certain conditions. All right, so if I want to find a number c so that the mean value theorem holds, you always have to check your criteria. I am okay in this scenario if you just want to tell me it's a polynomial, so it's continuous and differentiable. If it wasn't a polynomial, you would actually need to do the derivative and make sure it is defined. Check your domain. So what the mean value theorem says is that this derivative has to equal the slope between the endpoints. So first I need to know the slope between my endpoints. If I put in 0, what do we get out? Okay. If we put in 2, we get 8 minus 2, which is 6. So slope y2 minus y1 over x2 minus x1 gives us 3. So what this tells me is my derivative is going to equal 3 at some point. So we do our derivative, 3x squared minus 1, so that equal to 3. To get rid of square, we square root plus or minus. Plus or minus 2 over the square root of 3, or plus or minus 2 radical 3 over 3. Okay, I wanted the number between 0 and 2, so which one am I using? I found 2 times, but I only needed the one between 0 and 2. Another sense of what this is telling us, we know that the slope between two endpoints is the average rate of change. Derivative is the instantaneous rate of change. So what it's telling us is that somewhere your average rate of change and your instantaneous rate of change have to be equal. I think it's easiest to think about it if you have an example involving speeds. Okay, if you're driving 120 miles in 2 hours, what is your average speed? 60 miles per hour. Is it possible to have an average speed of 60 miles per hour, but your odometer never actually, or your speedometer never actually hits 60? No, at some point you have to hit 60. So your instantaneous speed has to equal your average one at least one point in that interval. All right, let's look at this one. Suppose f of 0 is equal to -3 and f prime of x is less than or equal to 5 for all the values of x. How large can f of 2 possibly be? I should have added in here. Assume f of x is a polynomial. So that means we can use the mean value theorem. Okay. So my mean value theorem, if we look at our endpoints, we have 0, -3. And we have 2. I'm trying to find out how big f of 2 can be, so you could call it y, you could call it f of 2. Those are my 2 points. So if I'm using the mean value theorem, my slope, y2 minus y1, so minus -3 would be plus 3, over x2 minus x1. Has to equal my derivative. I want to find out how big it can possibly be. What's the biggest my slope can possibly be? 5. So if I'm trying to find my biggest y value, let's set it equal to our biggest slope. So if I solve that, the maximum value of f of 2 is 7. If that y is anything above 7, then my derivative turns out to be bigger than 5 there. We're going to do one more example, and then I'll give you guys some time to work. Just a couple results. If the derivative is always 0, then it has to be a constant. The only way the derivative is 0 everywhere is if you have a horizontal line. And the second one, if 2 derivatives are equal, we already know the only difference between the 2 functions is a constant. So we are going to just really only do straightforward problems on these, nothing too crazy. So let's decide if we can use the mean value theorem, and if so, we'll find our c. So my function is -x squared over 3x plus 6. All right, my criteria, it has to be continuous. Where is this not continuous? Because the denominator would be 0. So I know right now x can't be -2. So it is continuous on -1 to 3, since that -2 is not in that interval. Second criteria, I can't necessarily just look at this and know it's differentiable, so let's do the derivative. So low d high minus high d low over low squared. So my derivative turns into negative 3x squared minus 12x over 3x plus 6 squared. What can x not equal? Still just negative 2. That's the only thing that makes it undefined. Negative 2 isn't in my interval, so f of x is differentiable on the interval 1 to 3. So this is kind of like my scratch work so I could verify. I looked at my domain, made sure that value wasn't in my interval. Are we okay with that? So mean value theorem says somewhere this derivative has to equal the slope between the endpoints. So we have to plug in our endpoints. So if I put in negative 1, what do we get? Negative 1/3. And if I put 3 into my function, I get negative 3/5. So my slope, y2 minus y1 over x2 minus x1. Definitely not a beautiful problem, so feel free to use a calculator if you need to here. So I get negative 1/15 for my slope. So mean value theorem says my derivative has to equal the slope. All right. Let's just cross multiply. So I get negative 45x squared minus 80x equals, can I FOIL this and distribute negative 1 at the same time? Negative 9x squared minus 36x minus 36 quadratic, we just set it equal to 0. I think we can divide by 36 on both sides. Okay, does anything multiply negative 1 add to 4? Nope. So opposite of b, plus or minus the square root, b squared minus 4ac all over 2a. 16 plus 4. Negative 2 plus or minus the square root of 5. We only wanted between negative 1 and 3. So I can only use the negative 2 plus square root of 5. Now, that was a fairly ugly example. I'm mostly giving you nice ones. So your homework is probably 2/3 of the problems are just polynomials. So you don't have to worry about them not meeting the criteria. For the criteria, you can just say it's a polynomial, so I know it's continuous and differentiable. So there's only a couple that involve fractions or something, and they're not too terribly ugly. All right, are there any questions here? Okay, so I want to give you this handout. The front side, so it's kind of the opposite, but the front side is the mean value theorem, which is what we were just doing, so that the derivative has to equal the slope between the endpoints. The back side is Rolle's theorem, where you have to find when the derivative is 0. Okay, make sure you are verifying your criteria.